And we're live, I think. Yeah, I think we're live. Let's see. I see myself on the live stream. This is going to be a first time for me live streaming on Twitch, but this is super exciting. So we're going to be doing some IoT stuff. We have 3 hours. I think there's already 150 plus people watching live. So that's going to be really cool. There's going to be lots of tips and tricks that we will be sharing, lots of actual live coding. I will do my best to not do anything staged and actually even make sure that whatever questions you have in the chat, any ideas or anything you would like to see being explored live, I will do my best to try that. And I was just saying we, because I'm actually joined by Olivier today. So
Hey
Olivier,
guys,
how's it going? Good to
I'm fantastic.
yeah. Good morning, good night, good after. What time is it where you are?
It's 4 in the morning over here. I don't have a notion of what time it is anyways. I think I had a couple hours sleep down here, and yeah,
Like
I'm
like
ready for 3 hours.
literally a couple of feet away from your desk. That's where you slept,
Yeah,
right?
that's what we do. That's what I was told. You have to go to people for build. I was like, okay.
That's impressive. So yeah, that's so I'm Benjamin Cabet. I'm in France, so the time here is not too bad. And Olivier is going to be joining me, and we will have some great discussions, hopefully throughout the session. I've said that many times when teasing the session. It's 3 hours long, so that's plenty of time to answer the questions you may have. You probably, if you're keeping an eye on the chat, you've seen Toolbug already giving a shout out to also Glove Boxes. So that's our two friends, Paul and Dave, two cloud developer advocates, masters of all things IoT, Azure Sphere, Azure IoT Edge, AI at the Edge, and they will be. It's also a weird time for them, but they will be in the chat to help answer any questions you guys may have. And I think maybe Olivier will be their voice when it comes to, because I probably won't be able to keep track of all the great questions that you guys will be asking. But Olivier, of course, when you see a great question, just chime in. Your audio will be on, so just interrupt me whenever
Yeah,
needs.
yeah.
So that sounds great. What are we going to do? 3 hours. I don't know if some of you have had a chance to watch and to tune into some of the IoT sessions this week, yesterday and today at Build around IoT. But there's been lots of announcements around like real-time operating systems for embedded devices and much more. So we'll dive a bit into that, but also what I often, and I'm sure Olivier will agree, what we often realize is that actually building an end-to-end IoT solution, all the way from connecting your devices, maybe building the actual thing, the actual embedded device, to connecting these to the cloud, getting some connectivity lined up, be it Wi-Fi, cellular, whatever, and connecting that securely to the cloud, making sure that you store your data in the cloud securely, maybe do some data processing, anomaly detection, whatnot. This can be a bit complex, and I mean, I don't know about you, but usually whatever is the sort of the final kind of like solution I will settle in for my project, I like to understand what's under the hood, right? Some of you may have heard or may have played with some of the IoT solutions that are part of the Azure IoT landscape. Maybe IoT Central. Maybe you've tried IoT Central. IoT Central is this sort of build like ready to use solution for having essentially an IoT platform. It does a lot of it takes care of a lot of the complexity for you, but then I mean sometimes again I feel like it makes sense to have a look under the hood, to want to see what's going on and to make sure that whatever choices you will make when thinking about what's your use case? What is the data that you want to collect anyways? What is the kind of modularity and scalability you want to achieve? It makes sense to understand what are all the different building blocks, right? So what we will be doing today is look at a workshop, essentially for which the content is already online, and I will be following somewhat the instructions, maybe probably actually going way more hands-on than what the instructions like suggest you do. But this is a workshop around building an asset tracking solution, right? So it's all available on GitHub, and we can actually maybe have a look at what's there. So yeah, Azure, you don't see the link right there, but what the aka.ms will yeah, I mean, you have the link in the banner. So that I just opened this this page. If you have an MX chip dev kit, an IoT developer kit from Azure, feel free to try that anytime, even maybe during this actual live stream. That'd be fun actually. And yeah, what we will be doing is build a real-time asset tracking solution. So essentially, think about a company that has valuable, that's shipping valuable assets. Maybe we can call this company Contoso, and yeah, shipping valuable assets all around the globe. They want to be able to know in real time what's going on, right? I mean, they've been in the business of shipping assets for decades, but sometimes they realize that I mean the parcel, the shipment arrives at the destination, and it's been damaged, or it hasn't been handled as it should have, in terms of maybe like if this is a perishable good, maybe it should stay pretty cold, you know, that kind of stuff. So how can we build this kind of solution, and what is Contoso trying to achieve, right? So if I mean, and we will do some whiteboarding here, and making sure also that anyone who joins throughout the session during the couple hours we will be together, we will make sure that everyone can follow along. We will be doing some embedded development. We will be manipulating some time series database and so on. So making sure that we are we get the big picture right, and then we will dive into all the different pieces of the solution. So we have, yes, Benjamin, yes, Olivier, yep.
Everyone, it's a live stream that is not about going into deep C embedded code and do some real time stuff and so on. But it will still be interesting for people who are embedded developers. But it's accessible to everyone, and it's going to be super interesting to go all the way from the device itself and to what's happening in the cloud. And for you to realize that you have a bunch of skills that you already have today that you can put at use or use to work in the IoT space or to implement IoT solution.
Yeah, that's a very good point. And yeah, again, we both Olivier and I, we will do our best to like whatever topic you would like us to dive a bit more into. We'll try and do that as we go. This is not recorded, and we are definitely keeping an eye on the chat. So back to the whiteboarding. Yeah. Interesting. Who's sleepy cat? Probably. Interesting. Well, I sleepy cat. Hope you enjoy the session. Let me see. I want to do some whiteboarding, I said. So, Contoso, we have a bunch of parcels that we want to monitor in real time, right? And what are the kind of things that Contoso is looking at tracking? Right, we are looking at, I'll get there eventually. There we go. Come on. All right. We want to track the, in general, all things conditions about the shipment, right? What is what is the condition of the shipment, maybe the temperature, the humidity. We're looking at a company that does shipments all around the globe. It probably makes sense to know in real time, ideally, where the shipments actually are, right? Like the actual location. If we can, at the end of the day, display that on the map, that would be pretty cool. So part of the condition is where at a given point in time, where is the device, or where is the shipment, and maybe we will need some kind of device to track the condition. So we want to track the condition, the location. We want to be able to do anomaly detection, right? What do I mean by that? Most of the times, and like even before IoT, before going digital transformation, I think I actually have even like a nice audio transition for that.
It's time for some digital transformation.
It is digital transformation for Contoso. What does that mean? Well, that means that they will hopefully be able to do more than what they did initially. Initially, back in the old days, 99% of the time, the shipments were just fine, right? It's this 1% of shipments that get too warm or that get too wet, for which they want to be able in real time to do anomaly detection, right? So that's something else that we want to be able to do, anomaly detection. This is going to start to be pretty ugly. Let's see. I need to zoom out. Did you have yep. Mm-hmm. Yes, thanks for that, Restflix. I think we're having issues. I don't think right now there's anyone who's up and awake and able to change the title of the stream. Olivier, maybe you can check with our colleagues from the Twitch channel. But yeah, this might be an issue. Sorry about that. So. But I'm glad you guys are paying attention, and hopefully we can get that fixed. So yeah, we want to track the condition. We want to do some anomaly detection. Something else that matters to Contoso is being able to do all things data storage, not for the sake of it, but because like what they're looking at in as part of their digital transformation.
Time for some digital transformation.
They want to make sure that like they can potentially and hopefully soon enough start selling new services, right? That could be a great thing if their assets, if their parcels are somewhat smart and intelligent. Maybe they can have a sort of a premium shipping service where the customer pays more, but they know and for a fact, and that's going to be part of the manifest, if you will, of the shipment. They know for a fact that the condition of the device was fine during throughout all the transport, right? So so that's something else that we want to do is basically data storage, right? Data storage. In general, and I don't know how much we will how much time we will have to dive into that, but and I mean Contoso and just like many other companies or anyone today on the chat, I'm sure when you think about IoT, there's not a lot that's rocket science that is like new. What is new is trying to take devices, things like physical objects, sensors, actuators, and tie that, connect that, integrate that with existing solutions. And again, Contoso, it's not new for them to do to be in the shipping business. So what they want is a way to integrate with whatever existing solutions they may have, right? So integration. So that's going to be something else that we're going to be looking for, right? So that's tracking the condition. In probably even before doing anomaly detection, we will probably want to do some figure out how we're going to ingest data coming from the shipments into some form of database, and we will see some options there once we have the data. We probably want to be smart with the data and start extracting some insights. So that's going to be the anomaly detection point, and then we'll look into what it takes once we have the data, once we have insights extracted from the data, what it takes and what does it open up in terms of potentially building new services, new applications, like mobile applications for the delivery for the truck drivers, web applications for the actual customers, and so on and so forth. So yeah, that's what we're going to, yeah. Mm-hmm.
Using the database of your choice in the backend. And Pete was starting to answer. I think there's a couple of ways of seeing that. There's the notion of IoT Central, which is our SaaS offering, which is more of that black box. It is customizable, but at a high level, versus the PaaS approach, where you compose the different Azure IoT services. We'll walk you through, and Benjamin will walk you through the use of some of these core services in the PaaS way. We can discuss IoT Central towards the end if need be, but this one is really about, looking at what's under the hoods and playing around with the various bits.
Yeah, exactly. And we're going to keep on with the whiteboarding for a bit. What you will realize as we go through the sort of the high level architecture is that there's actually not a lot from a high level perspective. There's not a lot involved, and whatever path you want to go down when it comes to actually implementing your IoT solution, like Olivier said, whether it's something like IoT Central, whether it's more like combining and assembling the building blocks by yourself, maybe using some building blocks that are coming from outside of the Azure ecosystem, right? You may have some open source components that you want to combine as well. The high-level architecture is probably going to be fairly similar in any case, right? So what is it we want to do? Again, we are Contoso. We have our parcels. At the end of the day, what Contoso wants is build new services, right? I think we've mentioned this already. Maybe something like mobile applications for the delivery drivers. Maybe some like all kinds of applications, right? And this is going to be the realm of the apps that we want, the app or the apps that we want to build, and those applications might use some existing like stuff coming from legacy systems, right? There might be like an existing for some reason my stylus is not that great, but there should be like existing IT infrastructure that we will want to integrate with at some point, and that will be part of the apps that we want to build. So some data, some information will be coming from the legacy enterprise system. Maybe for Contoso, they have some stuff in Dynamics or that kind of stuff. But what they want to do is somehow take data coming from the devices, right? Remember, we want to be able to track in real time the condition from the parcels. So probably we will need to equip the parcels with some kind of sensors that will take care of monitoring the temperature, the humidity, whatever is meaningful to Contoso. Maybe the vibration could be nice for detecting when devices get when the parcels are dropped. We will need to get the data of those sensors into the apps, right? And so first thing we will probably need is some kind of wireless connectivity, and we'll see what are the options there. And then how do we get the data into the system, right? The data, I think we mentioned that Contoso, they wanna be able to store the data. So some kind of database probably, and I think I will need more space. Whiteboarding is nice, but it can be too much for my brain, not too much multitasking. All right, let's make some room. All right, the apps on the left-hand side, the database somewhere in the middle. How do we get the data into the system? Like the devices, very likely the sensors that we're going to use, they're going to be pretty constrained. Like we're talking, even like for the sake of cost efficiency, it's not like you're going to stick a computer to each and every parcel. So some kind of wireless sensor, maybe using some low power connectivity options like LTE or LoRaWAN, this kind of stuff. And you want to like connect the devices to your cloud infrastructure, right? I mean, at some point there is a chasm that we need to cross, and which is getting data into the cloud, right? And typically, what you will find and use is some form of what we call a cloud IoT gateway, and this is this is the cloud IoT gateway. So this is what the devices will be connecting to, and we will see what it takes to sort of provision, get your own cloud IoT gateway in your own cloud environment. We have this cloud gateway that will be our gateway into the rest of our services, the rest of the services we need for building a complete IoT application. Some of those services are the legacy stuff that we have as part of the legacy systems that Contoso or the company already has in place. Some other services will be something we need to deploy and to create and to tune to suit the actual business case that we're after, right? So, but I mean, at least we have an entry point into our cloud system. So from the cloud gateway, we will be figuring out how we can get data into our database. And one thing that will be important to consider is that IoT data is not your typical IoT data. It's certainly time series data, the values that you get from the field, from the sensors. The time information is probably something that you very much care about. That's what you're going to use for like having your data historian, for doing eventually also the anomaly detection based on some trends, some spikes that you detect in the flow of data. But I mean, yeah, it's time series data, but it's also data that needs to be contextualized, right? You want your like when you get 24 into the system, into a column in your database, it actually matters to know whether it's 24 as in 24 degrees Celsius, right? Because having this meta information is going to be pretty key to making sure that you make the most of the data that you collect in your system. So
that my voice, they don't hear my voice when you are in certain views in OBS. So I don't know if that's normal, but so typically the one with the whiteboarding, they don't hear me there. But no big deal. If you see my voice not being there, you can fix it or just switch me. But yeah, I wanted to add to what you just mentioned, the fact that IoT data more than any other one needs to be in context. And one like example I like to explain about that is that typically a temperature sensor can mean something, with a specific value in a room, and mean something different in a different room. For the same sensor, different values will have different meanings depending on the context. And context could be location, context could be time, and so definitely you need to think about how you're going to attach metadata or additional information around your sensor's data.
Yeah. And how about let's see. I think we should be good with the audio. Maybe Olivier can just say something.
Hey,
And
if
all right.
and now
Yeah.
if it's
Okay.
fixed, Pete, let us know on
Yeah.
the chat. We'll see. Thanks.
Yeah, I think that was definitely an issue on my side. Live producing while talking can be a challenge. All right, thanks, Pete. Looks like it's fixed. So data, we get data into the system. Raw data only gets you like to the first step of the solution, especially if we're looking at the asset tracking scenario. One thing that's going to be pretty interesting is to do some anomaly detection. Like, can we automatically, semi-automatically figure out when something's wrong with the parcels? They get too warm, they get too humid, too fast, which is even more of a problem, or an indication of a problem. So that's something else that we want to add probably to the mix. So that's going to be something that I will be calling anomaly detection. Let me just zoom just a bit for the handwriting to not be too ugly. But there will be something here that we want to do, which is the anomaly detection. It's still ugly. Not terrible though. Anomaly detection, but we'll switch back once we have our ugly whiteboard all full, and we'll take some notes in actual writing as well. But if we have this component in place, we will probably want to make sure that either the data that we get from the data store, or more likely the data that we get straight from the fire hose, from the sensors, we want to route the data through an anomaly detection algorithm or algorithms, and we will see what are the options there. When I said just before, automatically or semi-automatically, there's tons of options when it comes to extracting insights and information from data. Either you have actual models that you've trained based on what you know makes sense for your particular context, your particular data, or just in general, what's called unsupervised learning can work also pretty well. Just looking at the stream of data, we can figure out when there is a certain spike, right? So that's what our anomaly detection will be for. Could be interesting to see if the results from our anomaly detection we also store in the very same database where we have the entire history of data for all the parcels. Because again, as a customer of Contoso, if I pay more, I want to have the proof that that there was no anomaly whatsoever throughout the life or throughout the journey of the parcel. So we'll be doing something like that, and the data that we store in the database. At some point, we will see what's available in terms of APIs to make use of the data and sort of bridge the gap with the and make sure that we can actually build apps, and we can tap into the existing IT systems. So one thing that we will be doing for sure with the data is feeding it into. We want to build a map at some point, right? So what does it take to build a map? What's available in Azure and Azure IoT land to do that? You may have guessed maybe that we will be doing some cool Azure Maps stuff there. But yeah, so that's essentially what we want to build. How ugly that is, reasonably ugly. I think Scott Hanselmans didn't do any better yesterday during the keynote. So I'm not too, pretty happy with that. And like I said, let's make sure we have some. We take some notes and that we will be going through. So if I were to summarize the what is the whiteboard that we've just drawn, there will be several things that we want to build. We will we want somehow to connect an asset tracker to the cloud. So what does it take? Like, is the asset tracker something that we get off the shelf? Is it something that we feel as Contoso like we want to build pretty much from scratch? Again, many times during the session, you will see that there's options. So that's the beauty of it. So we'll sort of look at what it takes to connect an asset tracker, what it would take, and what tools we could use if we were to build one from scratch. But that's connecting the asset tracker to the cloud. We will need some sort of what I would call a data pipeline. This database that I had right in the middle of my whiteboarding thingy. What is it, and how do we set that up? How do we take the data coming from whatever we will have connected the devices to? How do we get the data and make sure that it's stored ideally in an efficient way, in a way that works even for decades worth of data history? So that's that's us setting up the data pipeline. Once we have that taken care of, we will probably want to see, I have temperature coming in from my my IoT devices. Let's do some anomaly detection. So that's going to be another step, and I will be sharing again in a few more minutes the workshop, which is linked under here. But if you're keeping an eye on it, you probably realize that those bullet points that I'm starting to put on there are are essentially exactly the same as what you'll find should you want to do the workshop by yourself. And in this workshop, the fourth step is actually all things maps, right? Maps. We want to we want to take advantage of the fact that we have not only temperature, humidity data coming from our devices, but also location. What can we do with that? Can we create some nice visualizations for the customers, for the technicians, for the delivery drivers? Let's see about that. And maybe fifth step is going to be profit, right? So I think that's what we have. Let me share my my desktop again. So the workshop we're going to go through is here. What is so I think pretty much all that's said in the introduction. You've seen me go through at length, probably already in the whiteboarding, and we have the notes that we just took. So connecting a device, what does it take? There's tons of options. I think, Olivier, we can probably discuss the different options there. But what I want to do for this particular live coding session is actually use a developer kit that some of you may have already used in the past. It's called the Azure IoT MX Chip Developer Kit. And this guy, we can decide. There's essentially two options that you can go for if you want to implement the workshop. One is actually build the code that this device will run, build it pretty much from scratch. And what that means is you will leverage the fact that this guy is essentially a microcontroller and a bunch of sensors, accelerometer, gyroscope, humidity, temperature, magnetometer, pressure, pretty much all we need for building a cool asset tracking device. So you could write a firmware that collects data from the sensors and sends the data at some point to the cloud. Probably you will want to use some APIs and some SDKs provided by your cloud provider, right? If you want to connect this guy to Azure IoT, it's likely that you will want to use the Azure IoT SDK. So we will see what are the tools available to develop and to build the code for this guy. Actually, for the context of the workshop, we'll be using a firmware, an application, an embedded application that's already been written, and we will deploy that on the dev kit. To be frank, for a company like Contoso, chances are they will want to use an off-the-shelf device, right? And I don't know, Olivier, maybe you wanted to, like, what are the options? Like, if I want to source a device that I want to connect to, like the Azure IoT and the Azure Galaxy, and we will look into more details what it means to actually connect. But what are the options? Like, is there like something like a device catalog, maybe, or that kind of stuff?
You should ask, because there actually is a catalog for all devices that are certified. Okay. So if you want to bring my camera up, so this is this website here that people can go to, catalog. I think the link might change, but I might have a shortcut somewhere. So catalog.azureitsolutions.com, and in there actually you'll see a bunch of devices that have been quote unquote certified. And when a device is certified, that means that it went through a set of tests that verifies that the device can connect to Azure IoT Hub and can also support the various features of IoT Hub. And we'll see that while we're going through the lab, that there are different things that you can do from a device when you communicate with IoT Hub. And one of them is sending telemetry data. We mentioned that a lot. But then there's also a notion of sharing a state with the cloud and basically synchronizing a state. And also have the ability to have devices offline that it can synchronize their states from the cloud, and when device gets connected, it can synchronize the state and get the commands and or eventually give some more information to the cloud. So these kind of features that IoT Hub supports need to be supported by devices for them to be in that catalog. So like right now, this is definitely not an exhaustive list of the device that you can connect to Azure IoT, because as Benjamin mentioned, you can use code. And at the end of the day, IoT Hub supports various protocols that are out there, like MQTT or AMQP, even HTTP actually, for connecting devices. And you can leverage some of these SDKs that we have, or write your own code, or use your own library in order to connect to IoT Hub, and to be able to implement or to add devices to your solutions. One thing I wanted to mention is the SDKs that we have are all open source. And we have them in various languages, because even though the majority of IoT devices out there will certainly be running applications developed in C and C++, because most of these IoT devices out there are microcontrollers that you program using these type of languages. But we also have support for .NET. In the form of C#, we have Java, we have Node, we have Python. So you can leverage any of these open source SDKs for you to embed onto your device. And as a matter of fact, you can simulate a device. We will see different tools you can use for simulation in your developments, but you can definitely have a device in the form of a Linux box that you wrote your own Python code, and eventually use that same Python code on your Windows box when you're doing development for simulating devices. So super interesting set of resources that are out there that a developer can find easily. I think we can have some links here and there. I'll add some links for the SDKs, but you can also really rapidly search that on the web and find these SDKs.
Great. So yeah, let's. We want to connect the device, right? So if I were to go through the instructions, one thing that it actually invites me to do is to create my cloud IoT gateway, which is what we call IoT Hub. So while Yeah, let's just do that, right? This is going to be live coding. So let's create an IoT Hub instance straight from the Azure portal. We can do that. Like Olivier said, we could probably do that with a handful of other tools. I could use the CLI to create and provision my IoT Hub. Could use VS Code as well. Yeah, let's just do it from the portal so that we get a chance to really look under the hood, like I mentioned in the introduction, making sure that we have, we understand what we're doing essentially from end to end. So creating a new IoT hub in North Europe. This is going to be MS Build live coding 001 pricing tier, how many messages I anticipate to send per day. I think that's plenty for getting started. Do I want to enable the Azure Security Center, and more specifically Azure Security Center for IoT? I probably do. Do I want to get alerts when I have devices like IoT devices that may be compromised, that for which automatically, thanks to a security agent that you can sideload like alongside your IoT device, automatically detect when, I don't know, you have a device that's gone rogue and that's starting to mine Bitcoins. You definitely want to detect that. So I'm enabling that. What do I want to create here? Do I want to tags? Probably not. And that's it. I mean, I want just to create my cloud gateway. Something else that I will need is as Contoso, I want some modularity in the way my sensors, in the way I connect them to the cloud. Like, do I want to bake right into the silicon of the device and hard code the endpoint where my device is supposed to connect when it comes to sending data, to checking whether firmware upgrades are available to upgrade the device? Or do I want to have something more modular where the device effectively gets provisioned and attached to a particular cloud gateway, like at runtime, if you will, like maybe based on the location. I have several cloud gateways all around the globe, a couple in North America, a couple in Europe, and whenever the device is connecting from an IP address that's closest to the European data center, it probably makes sense for latency, for cost, whatever. It probably makes sense to talk to a local IoT cloud IoT gateway. So that's something that you can add in terms of making your provisioning like part of your adding to your workflow the provisioning side of things, making sure that the devices, when they leave the factory, they're not yet attached to a particular cloud gateway. So we will use what's called the Azure IoT device provisioning service. So something else that we need to deploy in our subscription is the IoT Hub device provisioning service. And there we want to create an IoT Hub DPS. Should probably stick to the same naming convention as earlier, but I already forgot it. But at least let's make sure we are running in the same resource group, just for making sure all our stuff is in the same basket. So yeah, DPS is now being provisioned. So now is probably a good time to look at while the resource gets provisioned. Now is probably a good time to open up VS Code, right, and get ready to connect and connect our devices. So the MX chip, yeah. Mm-hmm. Mm-hmm.
your own IoT hub, and so forth, you need to think about that unique name endpoint, and then you're going to think also as well about how you access this endpoint from the outside. You're going to think about the VNet capabilities that IoT Hub now has, and the ability for you to integrate IoT Hub and all the IoT infrastructure into your own private network, because IoT and security for IoT is super important, paramount. So you need to think about these IoT devices that are out there will connect to a backend, and these devices, are exposed. And so, you have this IoT hub that will allow to uniquely identify the devices itself. It has that unique ID, that unique endpoint, and all of that actually is exposed on the web. Hence the single use name, or the unique name you have to put in there. Security. Once again, is something that forces you to do these kind of things. Unique name is one of them.
Yeah, absolutely. Let me have a quick look. I think there was an issue with audio once more. Pete, if you don't mind telling me and telling us what particular configuration was causing, I guess, Olivier to not be heard, or maybe it was me. But yeah, let me know, and I will try to fix this on the fly. And going back to I opened up VS Code. I have my MX chip now plugged in, like hooked into my laptop. Let me actually make sure that I close everything here. So the MX chip, the first time I plug it, gets powered on, runs like just out of the box. It runs some default Azure IoT sample code, which is fine to get started, but we want to build our own application, right? There's tons of tools for embedded development. There's actually lots of options. There's, when it comes to prototyping an IoT solution, and even more than prototyping, but lots of people are building on top of the Arduino IDE and the Arduino platform. A good thing is that the Arduino toolchain is essentially integrated in VS Code, so much that actually, when I just plugged in my MX chip, I have some like README and some guidance that automatically opened up, and that actually allows me to maybe look at, hey, you know what? If I am to go down the path of down the road of building my own device from scratch, let's see how easy that would be, right from VS Code. What if my asset tracking device was just sort of the IoT hello world, which is just blinking an LED? How about that? Like, how long does it take to open up a new app with, like, of course, blinking an LED shouldn't be terribly hard. So that's how the code would look like. And if I check, like, I think I need to maybe make some space for showing you that like, I want to make sure that my VS Code environment is configured to connect to my actual MX chip. And now what I can do is go there, Arduino, upload. What it's going to do, and keep an eye on our friend the MX chip over here. It's going to build the firmware, and well, that's going to be a pretty dumb firmware. It's going to blink an LED, and I'm sure we can call that IoT, in that it's not really connected just yet. But just want to make sure that you were you were familiar and aware that embedded development you can do straight from VS Code, right? And so code is being flashed. And once that's done, we should see the user LED. So where is it? Can I point it with my finger? Maybe this one, this guy over here, blinking every second. So that's that's the embedded app that we are running. Again, that's nice. At least you know that you can build your app straight from VS Code. But we want to jump ahead and make sure that we actually do some real-time asset tracking. So there is somewhere in the
It's one of the views where they don't hear me. Okay, so now they hear me. But that other view
Okay.
just before, I think they wouldn't hear me. But last time I was asking about the debugging capabilities with the MX chipboard, and that's one that actually is pretty interesting to just mention. So the device itself has a component that actually allows you to do debugging from a component from STMicro, and actually you can from VS Code do cross debugging code running on the actual device. And in VS Code, you put your breakpoints, and you can do your typical F10 F10 in the code while the code is executing on the microcontroller. It's pretty darn cool. And the team that Benjamin and I are part of is called Developers and Devices within Azure IoT. And one of the team is looking at how can we extend that experience of debugging for embedded devices to other targets. And from Visual Studio VS Code, having the ability to do this kind of work and having this comfort of Visual Studio tooling for you to doing your debugging on embedded devices, which usually is done on a set of tool chains that are very often proprietary. They're like super expensive, and so we are working with these partners, the silicon vendors. We're maintaining these tool chains, but it's definitely work going on there to offer an experience very similar to the one you can see with the MX chip device in VS Code.
Yeah, absolutely. Let's see. I think I should have done that just earlier, but like literally seconds before you stopped talking, I actually created a breakpoint, hit F5 in VS Code, and just want to show Lasamat, the debugger in action. Let's see. I think we need to, it's deploying the code once more. Let's see. Yeah, programming, LED blinking. And once we have the code redeployed and the MX chip switching to debug mode, we are effectively debugging, which, I mean, I had no idea until a few months ago. It just works. That's really really neat. You have, I mean, you can set up watch points. You can do like whatever you would do with when you debug embedded code. And I think part of the question from Lasamat is probably, I mean, you probably know that it's hard to do embedded debugging. It just works with the MX chip. So that's pretty cool. Back to the flow of the workshop. Like we want to like connect our asset tracking device. Contoso, I think, would have three options. One is going slightly further than the Blink LED example and start building on top of a platform like the MX chip their own embedded code for their own embedded asset tracking device. Another option is they have this embedded platform in the form of the MX chip, and someone else writes the code for them, and that's what they want to deploy and run on the embedded device. Or another option is what we've mentioned and what Olivier mentioned with the device catalog. They get an off-the-shelf, like the full package, the hardware and the software in it. So we're going to go for the option where the software already exists, has already been written for us. And there is actually, if I click on this link in the instructions, there is a pre-built firmware that I can use and deploy on my MX chip. I've just downloaded it. And what I will do, well, actually I will directly do save link as and directly save it on my MX chip. Like it actually exposes a file system when it's hooked up to your laptop or to your PC. So let's directly save the firmware that we get from the workshop content. We see our friend, the programming LED blinking. So we have like the firmware in the process of being transferred over USB. And once that's done, the device reboots, and this time around, it's not the Blink LED example anymore. It's something else. It's our app, or what is hopefully going to be the application that Contoso uses to get data from their systems, their embedded systems, into the cloud. And so what we should do now is make sure that we configure the device like maybe Contoso would do when they actually receive 10,000 of devices and asset tracking devices that they have, they want to onboard on their solution. They need to provision the devices, right? To configure them so that they know what is the cloud gateway they should connect to, what are potentially the secrets that they should use. I think I saw, I apologize, it was probably a good 15 minutes ago, but I saw some questions and some comments on how do you effectively send data from the devices to the cloud. It's usually either HTTP, AMQP, or MQTT. In the context, I think, of this particular app, we're going to rely on MQTT. There's, pros and cons for all the different protocols, but we're going to go for MQTT. And one thing we need to do is make sure that our cloud infrastructure is ready to get devices to connect to it, right? And so we have our cloud gateway. That's the IoT hub, MS Build Live Coding 001. Why does it say O block actually on that view? Interesting. Whatever. And the by the way, follow Olivier and myself on Twitter and all social media. I think you will. That's a good way to stay in touch and hear about some great IoT news as we share them. So the IoT hub, that's like the cloud gateway, we could bake right into the device the information to connect to IoT Hub, except that this won't make for a very modular solution. So instead, what we will do is set up a provisioning service that will and that can potentially be a front end to several IoT hubs along the lines of what I mentioned earlier. Think you have several cloud gateways in several geographies. You want to do some load balancing based on latency, based on geographical location. That's why you would potentially have several IoT hubs. So let's. We have just one for the sake of the workshop, but I think you get the idea. And the next step is to sort of whitelist the devices that we're going to connect, right? And so whitelisting the devices could be, so let me make sure that this actually completes properly. For some reason, it's taking some time. Yeah, I think we're good. Yep, we're good. So whitelisting comes in the form of creating some enrollments. So do I want to whitelist based on the identity of my devices individually? And by identity, I mean something like maybe a certificate, right? Or some form of pre-shared key that the device manufacturer will have baked right into the device. And that's what you're going to use for enrolling and connecting the devices. Or you can do something which is more based on a group of devices, have some form of intermediate certificate in terms of PKI and X509 based authentication and authorization, or something based on a symmetric key, right? Which is what I'm going to go for in the context of the lab. But you could experiment with the certificates if you'd like to use something like a trusted hardware module. That actually there's one in the MX chip and there's one in lots of IoT devices out there. So that's one good way to have hardware root of trust based authentication. But yeah, so that's my asset trackers. This is what I'm going to whitelist in the system. How do I want the provisioning service to behave when it comes to load balancing between the several IoT hubs I may have? I don't, but I may. Is it based on a pure round robin? Is this based on the latency on an Azure function that will do the allocation policy? Whatever. I don't have several IoT hubs. So let's just create the enrollment group. And now comes the time where we need to to configure the device. And there's many ways to do that. In the context of the MX chip, there is a particular setup where I'm going to push a button and reset the device, and it's going to switch to configuration mode. In real life, there's tons of ways this could be done. Maybe this will be some kind of workflow and handshake where the technicians will go in the field and like actually activate the devices. Maybe they also press some buttons. Maybe at home you have some kind of home automation device. That sounds familiar as well, right? Maybe you have a mobile app that you do that you use to configure the Wi-Fi. Sometimes it's super automated. Sometimes there's more manual steps involved, but that's essentially the activation and the provisioning part. And so what I should do, and again, that's for the MX chip specifically, now that I'm in configuration mode, the MX chip is in a specific state where it's waiting for me to connect over Wi-Fi, to connect to it over Wi-Fi, right? Which I'm going to do just now. This is where I crash the stream and like completely forget I was on Wi-Fi. I'm not. So we should be good. I'm currently connecting to the device. Interesting. Shouldn't take too long. Connecting. In the meantime, I will open up the web page where I should be seeing the stuff. What is the IP address again? Yeah, 0.1.
So while you're doing that, there was an interesting question and follow-up. So Paul was starting to answer to Samuel Zamarin, was asking, if my device is not supported by the SDKs, what should I do? And a good recommendation from Paul is to actually file an issue and indicate that this board or this typical target is not supported. The other thing is all these SDKs are portable. And the C1 actually is highly portable. It's a NC99 type of C, and so it can actually be used in various tool chains. And the porting of the C SDK has been made even easier with a new overhaul of the SDK that is now called the Embedded C SDK. And it's more modular, thinner, lighter. So it's part of the things that we are actually working on in our developers and devices team. And so porting the SDK is no big deal. And because everything is open source, it makes it even easier for you guys to make it on your own and starting from the various SDKs that we have.
Yeah, absolutely. So connecting the device, what does it take? Like setting up the Wi-Fi credentials, that's for sure. I just did that when I was off the live screen. And what is going to be the identifier for my devices? MX chip 001 sounds good. And then what's home? What's home for the device? Like, I don't want to bake the credentials to a particular IoT hub because potentially, I mean, like by the time the device goes live, the asset tracking device, many months may have elapsed between the time you develop the solution and you go production. You don't necessarily know what's going to happen, so you want to have this level of indirection in the form of the provisioning service, right? And the provisioning service, the information you need to identify it is one, the scope of the identifier of the device. So that's the one, and the key, the master key for the group enrollment that we've created. I should have copied that and saved that. But there it is. All right. Configure the device. Let's keep an eye on what's going on here. Yeah, go ahead, Olivier.
Yeah, I was saying this is the tricky part when you have a network connection over Wi-Fi and you have your Wi-Fi device in access point, and it's like, I need to change to the access point, and then I'm losing Wi-Fi. So if I didn't copy my ID scope and my key before on the web page, I'm screwed. And so you need to get this or have a wired connection for your laptop or your PC, and using the Wi-Fi for the device here.
Yep. And I actually realized that wasn't intentional. I removed the MX chip from the picture. You may think that I was cheating. I was not. The device is now connected. What is happening actually under the hood? How do we know whether the device is effectively connected? We're going to use some tools for that. There's several options, several tools that are available. I want to use one that I actually really like, which is the Azure IoT Explorer. Maybe someone will put a link in the chat. It's a fairly new one. It's an Electron-based web app that you can like easily run on whatever platform, and it allows you to manage and visualize what's going on for your particular IoT Hub instance. And so I'm going to open it up. So that's the IoT Explorer. And what it takes is it needs the credentials to access a particular IoT hub. So I'm going to get those credentials from my Azure portal. I want to, yeah, that's the one.
So I think that's interesting you mentioned this one. So the IoT
What's the
Hub.
one you use, Olivier?
So there's two things. I was thinking about the credentials for that you are actually passing to the tool. So the IoT Hub has basically two interfaces. There's one which is the service interface that you're going to manage the IoT Hub from that interface, and it will manage the credentials using these credentials you just used here, and so the specific policy that you define for a specific set of users with a set of authorization or permissions on your IoT Hub, creating a device, sending messages to devices, or things like that. And then there is the credentials that are for devices, and it's a different interface that the IoT Hub service exposes for these devices using the various protocols that we mentioned. So here what you are sharing is a specific key for a policy that is on the service interface side of things. And so in terms of tools as well, so you're seeing here Benjamin using the IoT Hub Explorer, but you can also stay in the comfort of Visual Studio or Visual Studio Code, where we do have extensions that allow you to actually interact with IoT Hub. And if I show you real quick, don't want to hijack you, but you have this extension for IoT Hub that comes in addition down there in your Explorer. And here, I'm able to connect to a specific IoT Hub and from there to see what's going on there. And then you can interact with your devices when there are devices. And you can also then use your command palette in order to create new devices and interact with these devices from the comfort of VS Code once again. So your choice of tool, not to forget about the Azure CLI as well, where you have an as IoT, and then you can work with IoT Hub, you can work with DPS as well. You can work with the different services that are in IoT from the comfort of your CLI if you are a CLI guy. So you definitely have options here in terms of how you're going to interact with your Azure IoT services.
Yes, that's great. So let me just finish something here. All right. So yeah, I'm going to use the Azure IoT Explorer. It's connected, like Olivier described. Essentially, it allows me to do anything on my IoT hub. So list all the devices that are connected, like send commands potentially to the devices. That's one thing that we didn't really highlight so far. But why is it different to connect a thing than it is to connect anything to sort of some form of messaging infrastructure. Well, when you connect a thing, you want to make sure that you have a bidirectional communication channel. It's not only about, hey, here's my temperature, here's my humidity. It's also about, hey, I'm the cloud, and I want you device to update your firmware, or I want you to run a command to toggle an LED or toggle an actuator, right? So that's why you need something like IoT Hub, right? And so we have apparently an MX chip 001 now connected to our IoT Hub infrastructure, and there's a bunch of things that we could do here in the IoT Explorer UI to get ourselves familiar with potentially the capabilities of IoT Hub, but more likely with the capabilities of our actual device, right? If I'm Contoso and I just received the particular version of the embedded software, like I just did minutes ago, deployed it on my hardware target. Now the device all of a sudden starts talking. What does it do, right? What are the capabilities? And there's one thing that's pretty neat in the Azure IoT ecosystem. It's called plug and play. I won't go like really deep into plug and play, but I think just the name, you get the idea. When you connect something to something, a scanner or a printer to a PC, a Windows PC, or an asset tracking device to an IoT cloud gateway, it'd be great if the actual data that's being transmitted, you have just enough of meta information and metadata around it to know what's going on, right? I have an asset tracking device. It's probably sending some bits and bytes on the wire. What is the actual meaning of that? And what you can do is, since this particular device is plug and play ready, you can like automatically discover the capabilities of the device. And either when you're building your app and like starting to experiment with the data, you know what's going on. But even like at runtime, that means that whenever a new device gets plugged into your solution, automatically you can make some choices in terms of, hey, this device, I've never seen this device before. This is not an MX chip based asset tracking device. This is manufactured by XYZ, but it tells me that it has some sensors. And as part of the sensors, there is a humidity. So I don't really care whether it's an MX chip based asset tracker or if it's one that XYZ just sold me. It's going to send a humidity. I know the humidity is going to be a double, and I know that I will be able on my map or in my time series database, I will be able to manipulate the data and visualize the data the exact same way. So several capabilities that the device exposes. As part of the sensors capability, it would appear that there is some humidity, temperature, pressure being sent. Is that really true? Well, you can use the tool to actually check that. We're now just subscribed to the feed of telemetry data coming from the device. I mean, not directly from the device. The device communicates to the IoT Cloud Gateway, to IoT Hub. And from there, it's pretty much business as usual when it comes to building a solution, or at least in terms of consuming the data. There is an Event Hubs endpoint that you can just get data off, and that's what actually the tool is doing here, and that's what our time series database is going to do in a few minutes. Our stream analytics algorithm, same, and we see data coming in. We see pressure, temperature, humidity. Yes, for those of you who do Celsius, it's getting warm in my room. Too much lighting, too much transcoding from my GPU, I guess, to send the video over to you. But that's one interface, one capability of the device that gives us sensor information. There's actually a few more capabilities we could look into. One is the position, missing kind of weird for a device that's very static and that doesn't even have a GPS in the first place built into it to send a location, but it actually does for helping with prototyping the solution. We have a device that that sends simulated location. And so if I subscribe to this particular interface, how does that go? And we see data being sent. I may have something wrong with my plug and play model, but you get the idea. Just ignore the warning. You see that the device is apparently moving, and I'll be curious to see where it pretends it is. We'll see that towards the end of the session. But that's for the location. Another interesting interface you may want to interact with and play with to make sure you're familiar with all the capabilities of the device. For this particular device, there is an interface that's called screen. And this time around, we're not talking about telemetry. We're talking about commands. So apparently, the model that describes the capabilities of the device and that the device presented to the cloud gateway the first time it connected, apparently tells us that there is a command that we can execute. So keep an eye on the MX chip. And we're going to send a command. So again, not directly. It's going to be our tool here, the IoT Hub Explorer, sending the command through a service API call to IoT Hub, asking IoT Hub to send a command on our behalf to MX chip 001 and to say, hello, Twitch fellows. Sending the command. Are you paying attention? Yes. Hello, Twitch fellas. Let's do it again. There we go. So this is going over the air, obviously, using MQTT for those who cared and who asked before. And that's that's our device. I think it's connected. I think we're pretty much done with step one. Am I missing something, Olivier?
No, I think you have a device that connects automatically and
check. Yep.
interacting with them. What you did in terms of visualizing the telemetry coming in, you can do that in VS Code as well. You can do that in Visual Studio. So stay in the comfort of your favorite tool for you to get going with your IoT devices.
Yeah. Do I want to demo that? I feel like I want to. Quickly. VS Code. I think, the only thing that this VS Code in particular instance, I have installed the Azure IoT extensions. I should probably show that. It's part of the goal of the live streaming session, show you all some cool tips and tricks. If you look for the IoT workbench, this is your entry point. If you install this guy, you should be all set for all things Azure IoT development, all the way from the Arduino extensions, the support for IoT Hub, IoT Edge, and probably more. There is a data simulator. I think we had a question in a previous session. You can also simulate data from this particular UI. But yeah, just to show you how simple that is to enable, I'm actually not signed in, but that should be quick. Signing in to my Azure/Microsoft account. Yep. Done. I can switch back to VS Code. Now it's connected. Signing in. It should show me all my Azure IoT subscriptions. I want to go for this guy. Oh, IoT Hub. That's the one. MS Build. And now that I'm connected to MS Build, I can do. I don't need to show you what's underneath this tree. You can imagine, right? Right click, subscribe to the data, send commands, simulate the device, etc., etc. So that's pretty cool, and we may come back to this extension later. We're done with first checkbox. Probably need to hurry up. Yeah. I think I fixed all of them, but yeah, folks, Olivier just talked, so if you didn't hear him, then I need to fix something in this particular cell. I would hope so. You're right. Yeah. I don't think people heard you actually on that one. I'm going to fix this just now. And so you'll be back Sorry about that.
So I was making dad jokes and no one heard me. That's what you're telling me.
Now they hear you. Careful. All right. Back to sharing my desktop. Back to the asset tracking workshop, trying to just have a quick look at like if we're done with connecting the device. The next section is about creating our time series database and setting up our IoT data pipeline. There's tons of options probably for you to do that. Tons of databases that will like do the job. One I particularly wanted to highlight is time series insights. Essentially, like out of the box, just works with IoT Hub and is meant for IoT data and we're going to create a time series insights instance and see how easy it is to get data flowing from our devices to this particular time series database. So like I've done with the other services before, just use the Azure portal to create a new time series insights. What information do I need to put there? TSI live coding 001 as a name. That sounds about right. If only I knew how to type. North Europe, putting everything in the same geography. I don't have to, but if I don't do that, I might be billed and charged for moving bits around across data centers. I might not want that. We're going to use the all latest and shiny features from time series insights. And now something like that's one of the cool tricks that I wanted to show you and like making sure you really understand what's going on under the hood. Time series insights will take several, it can take data from several sources from just Event Hub, right? Or from IoT Hub, which is in fact pretty much Event Hub. And it's the job of time series insights is to figure out, hey, here's a blob. And in this particular blob, what is the particular piece of information that represents the time, the actual timestamp? Sometimes like if you use Event Hub or IoT Hub, there might be a default timestamp, but sometimes you might want to use a custom one. And there is another important attribute as part of the particular blob is what is the element and the attribute that I should use to uniquely identify a particular time series. For our IoT data, I want to create a dedicated time series for each and every devices that I have. So essentially, whatever is the property that holds MX chip 001, 002, etc., is the property I want to use. So now, what is that? Like, I don't think I didn't show you all the code of my embedded application, but I'm not necessarily explicitly setting the when I send the temperature, the humidity. I don't like explicitly set that information. So how do I know where to find this this ID? And I shouldn't have closed my IoT Explorer because I want to show you something. If I connect again to the device and to the flow of telemetry coming from the device, we will see some like application data. Yeah, sure. Thank you, device. You tell me about the location. And actually, we see also there is a timestamp. Fair enough. But there's more to it. And if I show what's called the system properties, we will see that as part of the message that time series insights will effectively consume, there is one attribute that seems to be doing exactly what we want in terms of holding the information and the name of the device, right? And the unique name of the device. So that's what we're going to use as the property name. Now we need a blob storage account. I'm going to create a new one, blob storage TSI build. Definitely not sticking to any naming convention whatsoever. So this is where the database is going to be stored. And the good news with TSI is that it's using an open source format. It's called Apache Parquet. And that's where the time series data will be automatically put into buckets according to like what time they were received, etc., etc. And that's going to be our data store. And I also want to enable something pretty cool. Time series data, and even more so IoT data, you usually want to store the data for a long period of time, maybe for decades, right? And you want that to still ideally be reasonably cheap while still giving you the option for the data that is somewhat fresh, last week, last month, kind of stuff. You want this data to be accessible, still accessible pretty quick, right? And almost be in memory, right? And that's exactly what the Azure TSI warm store does. So how long do you want your warm store to retain your data? This is configurable. You may want to check out like the actual the implications in terms of pricing, but usually you will want some form of warm store, like especially if you're querying your last hours, days, or weeks of data really often. But that's that's all I need. No, that's not. I need to configure the event source. I can have one or several sources from which TSI will be pumping data. One is definitely going to be IoT Hub. My IoT Hub, which I can find automatically in my subscription. I want to make sure that TSI gets data of this IoT Hub. I probably want to create actually a dedicated access policy to make sure that only the data that TSI will consume, it will be able to make like have snapshots, etc. If something goes wrong, I want TSI to have its own feed, if you will, of IoT data. So real quick, I will just make sure to create a dedicated what's called consumer group in my IoT Hub. It should take literally a second to go in the built-in event endpoints section and make sure that TSI has its own consumer group. There we go. I might need to just trigger a refresh here. MSB on live coding. Is it there? It's not. Oh wait, sorry, no, access policy. I was confused. I could have created the consumer group directly here from the UI, but that's fine. I did it manually. What is the timestamp? Do I have a custom timestamp that my devices are sending? Nope. The default system timestamp should be good. Creating TSI, and there we go. While this gets created, I think this should be pretty fast, but any other options, Olivier, that come to mind in terms of storing data? Do you have like other preferences, maybe, or?
It depends on you know the architecture of your solution, right? If you want to store data for instant analytics versus long time storage, if you have a lot of data you need to put somewhere, and you know, care about the cost of storage. So you will have to think about, so TSI being a solution that allows you to do analytics on the flight in near real time on your data. It has a dual model of hot path or warm path, and also allows you to inject data from a cold path from a different types of storage, and then you can think about things like blob, right? So cheap way to store data for later analysis. You can look at Cosmos DB as well, right? If you have different types of data and you want to analyze that differently, you can think of open source solutions as well that are hostable on Azure. That's the easiest and more efficient, which is from IoT Hubs and directly to that storage account. So it really depends on the architecture of your solution and what you want to do with the data. One funny fact about IoT Hub, it allows you to implement some rules on the data flowing in, and you can route data. So if you want to store, you know, for long term all the data in a blob, but then if you want to apply a rule and say only data that has the field alert set to 1, I'm going to send to that other endpoint. You can create different endpoints for IoT Hub and decide where the data goes for, you know, warm storage, hot storage, or analytics on the flight, basically.
Yep. And yeah, on the topic of data routing and analytics, then the last question, which Toolbug in the chat started to answer is Azure Stream Analytics, does it come in addition to TSI, especially when it comes to analytics? What can be done with one and not the other potentially? Well, let's look at TSI and what it does. The way I think about TSI is one, there is what's called the Time Series Insights Explorer, so which is a tool essentially for your data scientists to do the analytics side of things, but somewhat manually, or at least like think about some form of sandbox where you can dig into the data, set up some maybe annotate the data to come back to it later when you identify when you catch by eye pretty much some anomalies. So that's the TSI Explorer. There is underneath the TSI Explorer, of course, the actual data store. And this particular data store is just meant to be like your where you store all your time series data. So in actually the next step, we will see how we can complement this data and augment the data with some anomaly detection that we may be doing this time around automatically with stream analytics, and potentially feedback the result of those anomaly detections into TSI. So from the portal, I created a TSI environment, and right from the portal, I can open the TSI Explorer. And by the way, I have no idea how we're doing in terms of viewership, but my guess is some folks have tuned in. Just a quick sort of reminder of what we're doing and building during those 3 hours. We're halfway through. We're building a real-time asset tracking solution, all the way from connecting an actual asset tracking device in the form of this guy that you see right here on the screen. We're connecting this device to the cloud, and the cloud, we're looking peeking under the hood of what it takes to set up all the cloud bits you may require for this particular asset tracking solution. So we are now looking at the data storage side of things, and we'll then dive into anomaly detection. I'm doing asset tracking. I want to know when a device gets too warm, too cold, too humid, or I want to see on the map where the devices are, right? So that's what we're trying to do so far. We've been doing lots of like actual live coding, starting from an empty Azure subscription, from a vanilla IoT device, and again, halfway through. Ask any questions if you need to catch up in the chat. TSI, just open TSI. Apparently, like if I look at this timeline, it would seem that over the past 30 minutes or so, there's been some event that TSI has captured. That sounds about right in terms of timing. I guess at 4 past the hour, that's when we first connected the device. And yes, Olivier, like you said, that means we probably need to hurry up. But I think we're also, I mean, that's great. We're diving into lots of cool tips and tricks. How do I use TSI, or more specifically the TSI Explorer? It's pretty straightforward, but there's quite a few things that I wanted to show you, both in terms of data visualization, but also what I would call data modeling. So my particular MX chip 001, I probably want to display the temperature and humidity as somehow as a line chart or something. Just click on the device. Automatically, all the properties, all the attributes that the device has been sending over the air through IoT Hub for the past 30 minutes, they show up in there, and we can directly be like, hey, yes, temperature, I care about. And yes, Benjamin's office and room is getting warmer and warmer. My bet is that it's also getting humid. Let's see about that. Actually not, but that's live telemetry coming from the device. If I were to have several, we could probably, and we would see them in the list here. We can do some fancy things in terms of, back to my point earlier of, this might be a tool for data scientists. I want to arrange the way I look at the data according to what I'm looking for. Like maybe I want to compare the the temperature and the humidity. So it might make sense to show them on the same quote unquote lane so that they actually share the same y-axis. I don't care about having a 4-second resolution in terms of like seeing pretty much all the samples and all the data points. I want to do consolidation in 30-second time windows, or even more, like maybe 5 minutes, in which case I can actually have automatically see the mean and the max for a particular time window. I do see the mean and the max. I could look at my temperature as rather than looking at the temperature as a line chart, which is actually quite helpful. I could think about looking at it as a heat map. And a heat map, like with this particular aggregation, we could easily identify if I were to put my finger, but my guess is that I won't be able to make the device any warmer than 32 Celsius, but I will still try. We should be able to see this in the heat map at some point, right? So that's, I mean, lots of visualization capabilities. We could even do some correlation. I want to plot, like, is there a correlation between the temperature, humidity, and like, yeah, I mean, I would need a third measurement here. Be like, hey, maybe based on the location, latitude, longitude, what is sort of the bubble and the scatter plot of the humidity based on the location, and even like. That could be useful. Let's see. Oh yeah, my finger experiment did work. So for the past seconds, the device got really warm, which we can confirm if we display a line chart. So that's helpful. But one thing that I want to leverage TSI for is making sure that my data scientists don't have to deal with the raw data. I mean, this is somewhat okay. I mean, probably my data scientists will know that the temperature holds a temperature information, but there might be other data that's not really meaningful for showing here in this particular environment. So you may want to leverage TSI as a way to model what is the what is your data? What is the meaning of your data? So I'm going to create a model for my asset trackers so that I want to actually display the temperature and make sure that, I mean, it becomes part of the model. And whenever an asset tracking device is being displayed in the TSI Explorer, it will be, like, yeah, we will have this information. We can even like decide that we only care about the minimum of the temperature, and this will become part of the virtual data set, if you will. But I'm fine with the average for now. And I think the humidity is something else that we will care about and that we want to make part of the model. And now that this new type has been described, we can associate, I should have used the singular form probably, but that's fine. We should associate the type asset trackers to this device so that when I associate that, and I'm going to go back to my Explorer UI and realize that this time around, hey, that actually makes more sense. Like, this is at least prettier. This is definitely human readable. And that's something that's interesting. In the context of asset tracking, something else that might be interesting. And I guess we sort of slowly drift towards like the concept of digital twin, which is like a super broad term, but essentially your IoT data doesn't mean much if you cannot put it in the context of what actual device produced the data, what relationship this data may have with what's already part of your, I would say, IT graph, right? I mean, this particular asset tracker physically may have also a representation in Dynamics or in SAP, whatever. It also has probably a physical location at some point. It might be in a warehouse. It might be getting delivered, hence in a truck. So what is I mean, how do I model those kind of hierarchies? In TSI, you have a way to describe some hierarchies, which I will do very briefly, and you just get the idea. My geography is going to be about the actual location of the asset tracking device, and there is part of the geography is having a country, a region, and a facility, something along those lines. So I create and I model this particular hierarchy. And here you could imagine, like I'm doing this manually, but you could imagine like keeping this hierarchy in sync with whatever is part of your like 365 model kind of stuff. But now if I go back to my MX chip, my particular MX chip, yes, it does belong to, it has a location, and it would be France, Occitania, and it's Ben's office, right? This is where the device is right now, and that'll allow me to have a slightly better representation in the TSI Explorer. And this is also something that I will be able to access through the TSI APIs. I will be able to access that information if I want to know more about the data than just the data itself. With that, I think we've already ticked step 2. What am I missing, Olivier?
I don't think you miss much about TSI. I think one thing that is interesting to mention is the fact that TSI itself comes as a not a SaaS, but you demoed all the interface that allows data scientists to navigate the data and browse it and correlate and so on. But TSI also comes with a JavaScript SDK that allows you to embed the data from your IoT devices into your own web app. And so you can see the various samples that are available out there using the JavaScript SDK for TSI. So you can actually build your own your very own and super rich UI with real-time data, and also implement analytics the same way you've seen that. So typically, if I look one of these samples there, hopefully it's logged to be. So you can see here with very little code in the back, and you can see all of that on GitHub, that you get some very rich charting for your device, and then you get the same features that you've seen in the TSI app that Benjamin was showing right there in your browser and embedded into your own app. So it's a very interesting thing to understand about TSI, is that it's not just about data scientists using the TSI portal. It's also about you exposing the data of your devices into your app in a way that is useful and leverages the power of TSI.
Yes, I am on mute, and I'm also tweeting in parallel. There we go. So thanks for that, Olivier. I think it's time to tick box number 2 on our whiteboard. Anomaly detection. We have temperature, humidity flowing into the system from the IoT Hub Cloud Gateway right now into TSI. Really makes sense to try and route it through some form of stream analytics processing engine to do stream analytics and do anomaly detection. Yes. So that's, I kind of spoiled like stream analytics engine. This is going to be Azure Stream Analytics. Let's have a brief look at the sort of the script for the workshop we're going through. If you're just joining us, we're going through aka.ms/IoT workshop/asset tracking, sort of as an excuse for our end-to-end live coding session. I haven't looked a lot at the instructions. I'm just trying to play it by ear here. But yeah, step 3, anomaly detection in the script, at least what it tells us and advises us to do is to rely on stream analytics. And what we want essentially is, take the fire hose of data, of telemetry data that we get from the field, from the devices, extract whatever information we care about, probably like spikes and dips in the temperature. In our case, that's what we care about for now, and once we have that information, feed that back into TSI. So Azure Portal, we will need to create a stream analytics job. How easy could that be? Let's see about that. Someone is praying for the session to be recorded. Well, please pray for the recording to work. I am recording right now, so we should be all set. ASA job build. No good naming convention still. North Europe. How many streaming units I need? 3 is going to be plenty, but yeah, let's just stick to the default. I want to run my stream analytics job in the cloud. You may realize that it also provides you with the option to run cloud analytics at the edge. I think towards the end, we will discuss the option of what that could mean. Right now, we have a device, an asset tracking device that directly talks to the cloud. So it doesn't really have much, if at all, edge processing capabilities. So it's not like it will be easy to oversimplify, to run, to do anomaly detection at the edge. But there might be other setups where we could rely on some form of gateway, in which case we would probably use the edge hosting environment. We'll try to discuss that later. Creating the stream analytics job. This one I think is really quick to create. It is. What do I want to do? I want to, stream analytics, and we have an example here of, in a nutshell, what it does. It takes data coming from one or several inputs, does stuff. Like you can actually write something that looks very much like SQL, and that data we take from the input, pre-process, cleanup, whatever, we send to one or several outputs. So first thing we probably want to do is make sure that we configure our inputs. Our input is going to be the data that we get from IoT Hub, right? And in to make sure we keep some best practices here, we're going to create a dedicated feed for Azure Stream Analytics to get data off IoT Hub, so that it doesn't, I think you get the idea. We don't want Stream Analytics to consume a temperature information, which then wouldn't be available for TSI, for our database to store. We want them to use two different data feeds. So the stream input is going to be IoT Hub. We're going to get data, so that's our input is going to be called IoT Hub, just for the sake of being able to identify it later in our queries. This is this particular IoT Hub instance, the consumer group. This is the one we just created, and the rest should, we should stick to the default. The messages are actually JSON format, and that's what the Stream Analytics job will be parsing and making available to us and for us to process in our Stream Analytics query. So that's our input, and then we need to create an output. The output is us. We want to send data into TSI, so we need to make data available to TSI somehow, right? And so for that, we're going to create, and there's probably several options to do that, but the way I'm going to do it is by creating a dedicated event hubs instance for essentially the messaging between the output of my anomaly detection and TSI. So that's data that's going to be produced by my anomaly detection algorithm and made available for TSI to consume. So this should be really quick as well. No cheating here. Again, we started with a completely empty Azure subscription namespace, event hub, build, North Europe again and again. The pricing tier, I probably could go for basic, but I think in the instructions for the lab, we actually go for basic. Do I want to rely on, am I expecting tons of data to come out of Stream Analytics, in which case I would want to enable the auto-inflate. Probably don't need that. Right, let's create the event hubs. Should take not too long at all. there yet. Or is it? I don't think it is. And once we will have our event hubs created, did I create it in the proper resource group? I think some doubts.
And I had to refresh a couple of times earlier on my resource group to see the service appear. Well, while you're doing that, eventually, if you give me the hand a second. So
Sure.
you've been integrating and into your job a stream analytics job, a machine learning, which is algorithm or model, which is about anomaly detection. But as a matter of fact, there is a way that you can invoke any sort of machine learning models and APIs from Stream Analytics, leveraging the user-defined function. And there's some documentation about this preview that you should definitely check out, because it's as simple as going down to the functions section in your Stream Analytics and selecting Azure ML Service, and then you can go pick the different Azure ML services that are available out there. So this is definitely something that you can extend. The anomaly detection native API that Benjamin is using is not the only thing you can do. You can basically leverage anything Azure ML within Azure Stream Analytics. So Benjamin,
Thank you, sir.
did that come up?
Yeah, well, you know what? I didn't click on create. I just I stopped at the review step. So now I think it's created. Let's see. It says in progress, but I'm pretty sure it's created. Is it not? Let's double check. Yeah, that's the one, 2, and the 1 never came up. So my yeah, I was on mute for some reason. I'm not. Event hubs created, so I need to create the namespace is created. I need to create an actual event hub for well, this is, I guess I can call it ASA to TSI. There we go. And this will be our messaging pipeline. One thing I want already prepare beforehand is making sure that there will be a dedicated consumer group for yeah, this is the consumer group for TSI to get data of our event hub. Oops. Instance, and there is something else that we need is a dedicated access policy for the Stream Analytics job to be able to like send data. We essentially what we are going to write in like 2 minutes is from the fire hose of data, of sensor data we get from the sensors, we get temperature, humidity, etc. We look at the history of temperature over the past 5 minutes. We try and see if there is an anomaly. If there is, we output a 1. If there's not, we output a 0 kind of stuff, right? And we put that, we post that, we send that to an event hub. So we need a dedicated policy for that. ASA send policy. I might require listen as well. Alrighty, this is also pretty fast. Let me see. Going back to the Azure Stream Analytics job. Now we are all in a good shape for setting up the input. The input is going to be, did I not create the input earlier? I have a doubt now. I did not. I probably got distracted to show you that we needed to do more than, and we wanted to make sure that's not right. Right. IoT Hub owner, we're going to consume data, make sure that we don't step on TSI's toes by making sure that we get our own dedicated consumer group. Yeah, I think I created that before. And then creating the output while the input still gets created. The output is going to be what is going to be the result of our anomaly detection. Where should it end up? Should it be made available on a live Power BI dashboard, in a table, in a blob storage? In our case, this is going to be in an event hub. So this is going to be event hub, or I guess I could call it TSI. It's like, strictly speaking, it's going to be event hub. Posting on this particular event hub namespace in this particular hub with an existing policy that I created, and that's it. Creating the output. Now, if I now I need to write the actual meat, the actual query, right? And just trying to get familiar with what Stream Analytics allows me to do. I think I mentioned that before. Selecting data coming from an input, doing stuff, maybe like narrowing it down to just only a couple columns / attributes that you care about, and outputting that someplace. How about, like, what happens if I select data coming from IoT Hub into Event Hub? What if I do just that? What if I test this query? What's going to happen? Like, it's essentially a transparent forwarder and proxy, probably an expensive one, but that's just going to get data from IoT Hub into Event Hub, and we're going to see the preview just now. Interesting. So that's essentially just as if I was looking at the data coming from IoT Hub directly. So it doesn't necessarily help me a lot. But what if I be like, hey, you know what? I only care about data, like if there is humidity in my input, that's only what I want to output in my Event Hub. So that's another like step to understand what's happening under the hood when we do Azure Stream Analytics. Fingers crossed, my Azure Stream Analytics query language are not terrible. Apparently they're not, except that I'm probably missing some kind of where, right? Because right now, even those data points where the humidity wasn't available are still being sort of selected, right? So you get the idea, but I could be like, hey, I only care about data where the humidity is above 51. And actually, I also want to display the temperature, something like that. So that's what we're getting towards. I can process the data. How about I do some anomaly detection? Now, what if I were you? I'm me, actually. I don't know how to write that query. And I'm going to browse for the Azure Stream Analytics documentation. Actually, probably a very close neighbor in the Azure docs to the page that Olivier shared just before. Olivier shared the page that explains how to set up your own custom ML functions and custom defined functions. I'm going to use a built-in ML / anomaly detection function that's available in TSI. And my query is going to be very, very, very similar to this one. So what will I need to change? And you can see that my query from earlier worked. All right, let's see. This is selecting data from the input, which actually in my case is not called input, it's called IoT Hub. Maybe I can create sort of like an alias from IoT Hub, and the output in my case, it's called Event Hub. So let's just make sure we get this right. And what it does is it looks at only a subset of the incoming data, namely the actual temperature, the time, and then it does some consolidation, keeping the time, some time-aware consolidation to be like, hey, dear Azure Stream Analytics anomaly detection algorithm, can you tell me if you're more than 95% confident that for this particular temperature, over the last 120 seconds, do you think there is an anomaly, yes or no? If there is, or if there isn't, whichever, it's going to be made available as part of this this object, which we then manipulate as part of the second half of the query, where we essentially describe what are the columns that need to be part of the output of our stream analytics job. Namely, we want the time to be there, we want the initial temperature to be there, but also the score and the fact that there was or there wasn't an anomaly. So what else do I need to change there? I probably want to make sure that the scores I have here correspond to the actual sort of topology of my data. I want to look at the last 240 samples. Like I want to do, I'm looking at the last 15 minutes. I'm too tired to do the math, but essentially my data is only sent every 5 seconds as opposed to the sample that we were looking at, which is every second. So yeah, we just essentially explain the anomaly detection algorithm, how many samples it should be looking at, and how often those samples are expected to be found. And something else that we need to do that not be done by the sample is making sure that we partition the data based on the actual ID of the device, because I want to make sure that it's not like I want to calculate just one anomaly for all my asset trackers. I want to calculate, and based on the overall temperature of my entire fleet, it's really something that I want to do per device, right? The anomaly is going to be per device. So I'm missing something here, which is an ID, which I select from essentially my input. It has an IoT hub dot. I don't think it's case sensitive, but just want to make sure I don't confuse thing. But yeah, this is going to be my ID. So the ID that I want to use for partitioning my data. I should be close enough here. Let's see. Save the query. Is my query still buggy? Interesting. And yes, I have one more. That can be right. That's better. Running my query. So it's going to show me a preview of what the output could or should look like based on the recent history of data. It's not yet actually sending to Event Hub. It will once I actually deploy my Azure function. I think we're in a good shape. Oh yeah, no. One thing that I'm missing is I only all those rows. I don't really care about that. Those are the times where the device sends data, but sends the humidity or the location, sends a data point which doesn't contain temperature information. I could keep this. I don't really care about having this. So how about, this is just SQL, where the temperature is not null, right? That's essentially how this should work. Testing the query once more. And then if the query works, we will actually deploy it. We will start being billed for the query. But the good news is that it will pump data into Event Hub, and we are just 1 or 2 clicks away to see from seeing the data into TSI. So there doesn't seem to be anomalies. I could actually try and trigger an anomaly, but let's wait for a few more minutes, saving the query here and making sure I go back on the homepage of my Stream Analytics job to actually start it. Do I want to start it now? Yes. In the meantime, what I'm going to do is make sure that TSI, my time series database that we're using to store all the raw data, not only consumes, so I'm looking at the event sources for TSI, not only consumes data coming from IoT Hub, but also consumes data from Event Hub. The Event Hub, the one, I guess we should call it the ASA to TSI Event Hub, whatever. This is just a fancy name. Which one was it? That's the one. What is the name? Yes. What is the access policy? We don't care. The default is fine. What is the consumer group? We want an isolated one for making sure TSI only doesn't mess up with other potential consumers and the other way around. All right, so this is done, and let's make sure that our query, Stream Analytics job, runs just fine. I think it is. We should actually see the monitoring thingy. Show some live telemetry. Let's assume that it just works. And now we're going to look at TSI. And like, of course, I still have only humidity and temperature there. So I want to change my the model for my asset trackers and see whether there is now a new variable that's available. Because essentially what Stream Analytics does is that it posts data to Event Hub, but with the very same key, MXChip001, for example, that the devices used in the first place. So we're, at the end of the day, in the time series database, we have in the MXChip001 time series bucket, we have the raw sensor data alongside the anomalies that may have been detected. Anomaly, is it there? Is it there? Is it there? Is it there? Not yet. Let's see. I need to double check whether this guy just works properly.
I think you need to have had an output at least for that to show up, right?
What's that?
You need to have the anomaly to have been detected at least once.
I don't think so, because it actually sends zeros when even if there is no anomaly. So I'm actually thinking.
Oh, it sends the scores. It sends the score, not just the.
Yes.
Yep. I see.
Let's see. Let's just double check. Okay, the connection to IoT Hub is fine. Just making sure we're connected to the. Well, I mean, yeah, our testing just worked. So. Oh, there we go. Yeah, I guess it took a while maybe to because what's happened is that the Stream Analytics job, it actually there is in the built-in event endpoint for IoT Hub, there's actually a built-in cache, which means that I think by default it's like 7 days. So whenever you have a new consumer, someone that never showed up and was like, hey, IoT Hub / Event Hub, what is the data that the devices sent recently? If it's a new consumer, it gets whatever was piled up for the past few days or hours, which is exactly what happened, which is why we had Stream Analytics process 1.46K events at once. But now we should be good, and we have outputs. So I think we're in good shape. So now if I go back, yes. So far everything worked, so it better stay like this. Let's see. Oh, that's not good. Null. It's kind of a sign that I missed something. This is live coding. We'll get this fixed. What am I? Oh yeah, I forgot to make the ID part of the. So I need to stop the query now. I should have make this more interactive and ask in the chat or ask you, Olivier, what I was missing, but I think I found it. Like here,
you're asking me. I'm sleep deprived right now.
Yeah, well, and it's not even deprived. It's like, I mean, just sleep doesn't exist for you for the next 24 hours, for the past and next 24 hours.
Exactly.
Let's see. All right, stopping the job. Yeah, there's one thing I missed. I said that Stream Analytics will push the data to Event Hub and just pretend it's data that's been produced by MXChip001, except that it's not what was reflected in my query. It's still stopping. Stop. Just stop. I guess I didn't confirm. Did I not? And so what we're missing in that particular query is making sure that as part of the table, if you will, that we output in Event Hubs, the actual ID is part of the output. So let's get that fixed as soon as, yes, it stopped. Query. And I really do mean it when I said part of the session, the goal of the session was to look under the hood and to understand what the heck we're doing. That's exactly what's happening here. So yeah, when I do the anomaly detection, I have sort of a sub-query where I get my device ID, my time, my temperature, and my anomaly score. And then I take that and do some further processing, like extract the actual score and call it the spike and dip score, extract the anomaly and call it blah. But what I didn't do is make sure that I also output the ID that I get here from this query, and make sure that I call this exactly. Oops, yeah, sure. I created a mistake, but once I save, we should be fine. Righty. Yeah, stop complaining. I will get this fixed. There we go. All right, I feel like we need to test the query just to make sure. And now we should have another column. The first column will be mxchip001. If it is, then we're good to relaunch, restart the query. It will catch a few more. There we go. We're all good. So essentially what we're seeing here, just prior to deploying the function, is we see data that's in a good shape for being consumed by TSI, because when TSI will see this data coming from Event Hub, it will be like, okay, IoT Hub Connection Device ID, that's the name of my time series. I do happen to already have one, so I'm going to take data and add it to the existing time series. The temperature, it's actually going to add to what we already have. It's probably not the best idea, but what's nice is that we will have two more attributes as part of our time series, and that's perfect. So let's launch the query. I think this time around it should take, it should be faster. We can probably keep an eye on the monitoring. Well, let's see. Let's see. I can actually pay attention to the chat. Great question from the latest question in the chat is, what are we making? We are making an asset tracking, a real-time asset tracking solution where we're going through all the steps that that you may need for building an IoT, an asset tracking solution, all the way from sourcing whatever is the device you're going to use to monitor the temperature, the humidity, potentially the GPS location of your things, getting that connected to the cloud. We've done that already. Data gets ingested into Azure essentially and made available through event hubs. So once it's available that way, we have a data pipeline where we can store the data. That's called Azure Time Series Insights. We are playing with it right now, and we are even doing more than just storing the raw data, since we're also now doing some real-time live anomaly detection. So we are just about done with that one, and then we're going to visualize the data on the map. And yeah, that's what we are doing. The interesting question from, I want to make sure that I answer that one. The 95, you see here, Mr. or Mrs. Abatikar. This is not 95 as in Celsius. What this does, what this says is trying to reformulate, and this is me not having a clue actually about the stream analytics mostly, but I know what this does though. What this does is stream analytics for look at the data that's coming, look at your stream of data, aggregate the data by and partition, group the data by means of the identifier of the devices. So create buckets for asset tracker 1, asset tracker 2, etc. For those buckets, look at the last, 20 minutes. Look at the last 20 minutes. And in those 20 minutes, there's actually, you should expect 240 to find 240 samples, because the devices are sending data every 5 seconds. So stream analytics, you will find samples more or less every 5 seconds. So on this particular period, look at the temperature, and if you realize it's going out of sort of an envelope with and is spiking or dipping with more than like 25% of like level of a threshold, if you will, trigger an anomaly. Now, what exactly is behind the 95%? I don't exactly know. It's probably a mix of looking at the standard deviation, at like the average, the floating average, and so on. But at the end of the day, tweak this particular number, 95, maybe for you it will be 70 because you have temperature that varies quite a lot, and or tweak the time window, which you feel is adequate for knowing what is good or what is not. But that's what the 95 means. I hope this answers the question. It was a great timing though, because it gave me an opportunity to make sure that the job is now running. Yeah, it is. So now what am I looking at? For the types, the asset trackers, I want to make sure that my data scientists, when they will look at the data, I want to present them with the temperature, the humidity, but also the fact that there is or there isn't an anomaly, right? So something very human readable here. I could provide them with like the actual, the actual score. That's one. We could definitely do that. The spike and dip score. That's something we could just display. Not super. I mean, this might be useful for some data scientists. They will look at the score to do some advanced querying and so on. But my guess is that they also want something such as what I was getting to just before. Anomaly, yes, no, which is going to be not a number, but rather a category.
You want to change your screen so we can see what you're writing?
Ooh, could have told that earlier. Thanks. Thank you. All right.
I was giving you more time to change it yourself, and I was like, maybe not.
Nope, not sleep deprived. Only over 2 hours in the talking. I will briefly show what I did just before, but I'm just gonna do it again. In my asset tracking type, I want to make sure that my data scientists have a very approachable and human readable version of all the variables they may care about. One is probably the raw anomaly score. This one's easy. It's at the end of the day no different than the temperature or the humidity. So that's the score. I want to display it, and this will be available to my users. Another one is the fact that there is or there isn't an anomaly. And for that one, I'm going to create a category. And rather than displaying 0 or 1 as numbers, which, I mean, you could still display on a chart, but not that useful, I want to display the is spike and dip anomaly number as whenever it's 0, it's okay, it's fine, it's green, all good. Whenever it's not 0 and whenever it's 1, it's been KO, and that's red, not supposed to happen. And sometimes I mightn't have an anomaly, so I need to define that category as well. And that's it. Saving. Fingers crossed. So now we have a new model for our devices, which means that if we go back here, oh, that's interesting. Is my device not sending data? Let's see. I think my device stopped sending data for some reason. So I just restarted it. Let's see. But in the meantime, we should still have anomalies for data that came in the past, though. So we still should be in good shape. Although my device stopped talking, my job, I think my job ran on all the data history. So let's see. I want to display the score. Not even to display, that's going to be interesting. I want to display the anomaly, yes, no. Let's see, I need to probably zoom out. Oh, there we go. Just make sure that I display the temperature as well. All right, so yeah, for some reason my device stopped communicating for the past 15 minutes, but now it's back in business, and it's been for the past, what am I looking at? Well, for the past 7 minutes actually. Let's make sure we look at data in 5 seconds or even more. 15 seconds, zooming out just a bit. All right, apparently there's no anomaly, which is, let's make sure we display the temperature, everything in the same line. Let's see. the score right now, I don't care about. All right, temperature for the past few minutes, going up, down, but not like huge amount of variations. Now, this is where we'll see if the demo really works. I'm putting my finger, so hopefully 36, 7 Celsius-ish on the temperature sensor. And we're going to refresh. That just worked, did it not? What are we looking at? We're looking at the temperature, which suddenly, abruptly went up, and our machine learning model, and which is like built and baked into Azure Stream Analytics, based on what it's seen before, realizes that it's not meant to happen. Yes, the temperature for the past hour or so has been, or for, like strictly speaking, for the past 20 minutes, has been fluctuating plus or minus 1 degree, I think. Now that's more. Now that's plus 3 or 4 degrees that we're looking at. This is not meant to happen, so this is an anomaly. And like this is an anomaly with more than 95% level of confidence, and then we're back to normal. Once the sensor starts cooling down, we're back in business. We're back in the good shape, right? And we could probably, rather than looking at the category, we could look at the raw anomaly score. But I think you get the idea. Like rather than showing OK or KO, we could like directly look at the raw, let's see, the raw anomaly score, and it went below 0.05 at some point, which is like below the threshold that we set. And like I said before, you can tweak the threshold if you realize that detecting anomalies like doesn't work out of the box for your particular use case. But yeah, that's I think we can tick one more box. That's it. What did I forget? I think one thing that I think we said we would probably mention, Olivier, is for those of you, I mean, like the further we go into the sort of the implementation, the closer we get to this is not IoT. Like this is just IT data manipulation as usual, which means that at Contoso, that's the name we gave to the company for which we are implementing the asset tracking solution. At Contoso, there might be some folks who are very much who are fans of Power BI, right? And they want to like create fancy dashboards, correlate data they get from CSV data files in SAP, whatnot. They want to use Power BI. The good news is that TSI natively supports Power BI. So I can very briefly show it, but it's all in the docs, obviously. But anytime you want to sort of move and switch from TSI Explorer to Power BI, you can, well, maybe like download the raw data. That's also an option, but you can just connect to Power BI. It gives you a string that you just paste in Power BI, and you have the exact same data we're looking at here in this view. You'll have access to in Power BI, so you will do your pivot tables and all that kind of stuff, right?
Yep. So you get the best of both worlds, right? You get the TSI power of analytics on timestamps data, and then you get the visualization that is fully customizable on Power BI. One more thing, actually, other digression that is interesting to note is we've been talking about running anomaly detection in Stream Analytics in the cloud. And we're talking here about IoT scenarios. And so there's one thing that actually is important for people to understand is that we have the solution called Azure IoT Edge that allows to bring some of these workloads that are developed in the clouds down to the edge, as close as possible to where the data is generated, to the source of it. So think of the scenario that you have here, Benjamin, where you're actually transporting goods and you want to monitor the state. And you want to detect that anomaly in temperature. Well, if that device is not connected because it's not in range of whatever network, it's under a tunnel or it's at sea somewhere, then you might be in trouble. And so you need to be able to implement this magic, this intelligence on the edge. And so we don't have time to dig into that today, but it's definitely going to be a good topic for a follow-up live coding session, because I think this one is not going to be the last. I think it's the first of a nice series. And so we will talk about IoT Edge and how you can bring jobs like stream analytics, machine learning, and others to the edge, leveraging Azure IoT Edge.
Yeah, and shout out to our moderators in the chat, Paul, aka Toolbug, and Dave, aka I forgot, like Glovesbox something. Those are Paul just posted a link to get you guys started with IoT Edge, so you should check it out. But yeah, like Olivier said, there's tons of options for building the solution. The goal of today's session was to give you a sense of how this works in general, and like you may want to adapt. I think we are nearing the end of what we need to build. Just before getting to the profit part, is how well we visualize the data. One thing that we haven't been paying attention to is the device, although like it's very static on my desk right now. It's actually sending latitude, longitude, altitude. It's simulated one, but don't tell. It doesn't matter, right? It still gets sent alongside the temperature and the humidity, so it's just as if it was a real asset tracker. So what can we do to visualize the data on a map? And for those who are just joining us, we are near the end of this particular workshop that I feel like I need to make sure that we have the URL properly showed here, and I need to move even more. This is what we're going through. Sorry, I'm actually missing. Am I missing something? No, this is actually URL. Getting confused. There is an AKAMS link that will be put in the chat as well. And step 1, connecting an asset tracking device. We've already done that. Setting up data pipeline, we've done that. Anomaly detection, we've done that. Map visualization. How can we achieve that? We have data that's being stored and stored ideally, probably for long time in time series insights. That's what it's for. And so the data is now available for our apps, right? The apps that we are going to put in the hands of our drivers, our potential customers. And so how can we go ahead and build, we're going to build a JavaScript, a Node.js app that uses the APIs that TSI exposes to access the data store, like essentially the very same APIs that we are accessing through the TSI Explorer to dig into the data. We will access with our own own custom application, and we're going to need some way to do mapping, and that's Azure Maps. So I don't know if you guys are familiar with Azure Maps. If not, you should check it out. And I need essentially to add to my Azure subscription an Azure Maps instance, and this is where we're going to see lots of cool tips and lots of cool demos of the what Azure Maps allows you to do. Creating an Azure Maps instance is really straightforward. Azure Maps build 001. Depending on the kind of features you want to use, like reverse address lookups, whatever, you may or may not require to go for S1. The sort of the top tier. I'm going to use it just because I want to show lots of cool features. Creating the subscription. There we go. This one is also, I think, fairly fast to deploy. And this is where this is called live coding. I realize we haven't written a lot of code besides maybe the Azure Stream Analytics query, which we wrote from scratch, just with some help from the documentation. But now, if we are to build a web app, there's going to be more code involved. So we will need to manipulate the TSI APIs for getting data and maps to do map stuff. Like if we're building a web app, we probably want to use the JavaScript web controls to have like the ability to zoom in, zoom out, create some nice markers, etc. That's what we just did. We just created an Azure Map instance. It comes with like a primary key that I'm going to paste. Feel free to steal it. I'm going to just scratch the Azure Maps instance. When
So I
you're
don't know
done,
if you I don't know if you mentioned that, but it's super important that people understand how powerful Azure Maps is. It is your own instance of a service of mapping. So your data is going to be in your own subscription, on your own data set and storage, and you're not going to share that, and you're going to get all the power of your own instance of Azure Maps. And this is one of the big differentiator I'm asked very often about, hey, what's the difference with Google Maps and Bing Maps and other mapping services? Azure Maps is the enterprise ready, also IoT scale ready, personal and customizable mapping service. So that's something that's kind of important. And we have some very cool announcements at Build. So you should definitely check out the IoT Show episodes that we did about the indoor mapping as well for Azure Maps. It's just been announced with Azure Maps Creator. It's just my...
Yeah, I was telling you, I think earlier today, I wanted to put something together to add to the live coding session. I just didn't have time. But of course, in the context of asset tracking, indoor mapping makes a lot of sense. You have your devices and your assets moving around in trucks. So this one is easy to map on a regular map. But once your devices / assets, valuable parcels and stuff are in a warehouse, how can you visualize and locate them? So that's the idea. So one thing that the workshop tells us to do at this point, right? And again, check it out after the session, and hit me on Twitter, or I think actually I should share my Twitter handle, but I think you got it. One thing that this step tells us to do is, hey, you know what? As part of the workshop, we've actually prepared some code in this repository that you may want to use. So we're actually going to clone this particular repository in VS Code, which I realized we didn't really use that much until now, but I think that's also nice because we actually built a real solution without necessarily writing lots of code. But let's clone the repo. And there's a few things that I will want to show you there. All right, cloning in this, there. I feel like I should have done like the Twitch thing of having a nice trigger for when I have a cool tip that I want to share with you guys. This one tip is to encourage you all when it comes to testing, tinkering, playing, developing against REST services. You may know of tools and use tools such as Postman. Postman is great. It actually has some nice features, I think, like for like storing your queries in the cloud so that you can find them on your different machines and so on. I actually like to go even further and store my test queries in my actual GitHub repos. So the GitHub repo I cloned here for the map visualization step, it has a query, or rather queries, stored right into the a file that has the .rest extension. And this particular .rest file extension is something that the VS Code REST client, which you should install. I think it's part of the top 5 VS Code IoT extensions that I blogged about a few months back. You can search for that also if you'd like. If you have the REST client, you can easily share with your coworkers some. We all have those queries where you want to easily recreate a new environment from scratch, do a bunch of posts to recreate your database, to trigger a bunch of templates and whatnot. So that's that's a really, really cool tip that you should keep in mind. And so that query that's part of the repo has a bunch of things that I can actually try and play with. The only thing that is missing, and that's not part of the public repo, is the secret key for accessing Azure Maps. What if I want to get a location from an IP address? If I look at the Azure Maps documentation, it will explain and tell me that there is a geolocation endpoint, or rather geolocation/IP, for which if you pass an IP alongside your subscription key, to a get, you to get. And this is not my actual IP, so if you want to, yes, this is in France, but don't do crazy stuff on this person's IP. There is another endpoint API for getting routes, computing routes. I want to go from Seattle to Redmond by car. I want to go from Seattle to Redmond by car. Send request. Automatically, I get, and I mean, this is just one API call away. I get all the information I need in terms of how long is the trip going to be. And this is actually taking traffic into account. And what are all the waypoints along the way. If I were to not go by car, but rather be a pedestrian, let's see how bad traffic is. Right now, it takes about 20 minutes if I were to walk. Oh, that's way longer. Don't walk from Seattle to Redmond. Don't do those 23 kilometers. Something else just to call out, the REST extension and Azure Maps in the same time. And this will be a segue for Olivier to show even more Azure Maps capabilities. But one thing that I want to show you is Azure Maps as an API to render tiles, and I'm doing it like as if I were developing the solution. Like my way to do this is just, I know this is a feature that Azure Maps has. What is the docs page that explains me how to do it? That's the one. You can render a tile. So you give the format, whether you want PNG or like vectorial, vector, the coordinates, the zoom level, etc., and you can render a tile. What I really like about the REST extension, and I need to call that out, is if you look at the bottom of the doc, there is an actual sample. This particular sample query, so, and again, this is something that I will be able to commit in my GitHub repo later on for others to find later on. And for some reason, I'm struggling to find the pound sign on my keyboard. That's crazy. Render a Europe tile as PNG. I want to explain to my colleagues how that works. The only thing I need to do, copy, paste. It expects a subscription key. Well, actually, that has to be just curly braces as per the REST VS Code extension syntax. That's essentially it. Send request. This will give me invalid key. Oh, it's double curly braces. There we go. PNG file with our map. This allows me to really quickly do some tests. Of course, I could be using like a different zoom level, and this will give me like way more, different as in this way. Whoops. Well, you get the idea. Yeah, messing up with the zoom level or something like that. But there's actually plenty of options, and of course you can also chain your queries, right? What is the for a particular address? What is the latitude and longitude? And then for this particular latitude and longitude, what is the tile? And you end up with a PNG file that is very much like a static one that you can cache in your application if you'd like to, and to not hit the Maps API too often. And that's just like one example that's using the REST APIs. Olivier, I'm pretty sure if I am to open your desktop like just now, you have the Azure Maps samples open, and this is more with the we're we're doing good, right? This is more
Yeah,
using
yeah, we are.
the web's the web widgets, right? And so I don't know, like there's what do I
Yep.
see? Animations. I think there's probably heat maps in there. Tons of cool
It's
stuff.
just crazy. So they have a counter here that Ricky Brunrich, who was one of the lead PMs in the Azure Maps team, has put together. There are over 200 samples, code samples on that webpage, right? So it's Azure Maps code samples.azurewebsite.net. So you should definitely check it out. It's a GitHub project, and basically they created interactive samples for all the Azure Maps features and the APIs or capabilities of the web SDKs. So you can actually navigate everything that can be done with Azure Maps into your app. And I will not detail them, but just want to highlight a couple of them while I'm going through. You can definitely put together all of these features in a and deliver a very rich interface. The other thing which is very interesting is the capabilities that Azure Map has. Like typically, and you can just run samples there, like loading very large GeoJSON files is something that actually can be something that some applications struggle with, and you can see Azure Maps actually dealing with that super smoothly. People who are actually involved can in this kind of mapping application can understand that. Another thing which is super interesting about Azure Maps is the fact that it integrates with some of our partners, third-party data sources for traffic data, for things like commute information, things like weather data. We have a deal with a partnership with AccuWeather to get weather data from them. And so you can definitely invite you to go check out that page, navigate through all these samples to just understand the extent of Azure Maps capabilities and what you can do in your application. Not just IoT, by the way, any kind of application that requires geolocation and geospatial data. We have some episodes with Ricky on the IoT show as well. Shameless plug again. And you should definitely go check it out, play with that, and discover Azure Maps as part of your application. I think it's something that is pretty interesting to play with.
I'm sorry. Awesome.
Are you still with me?
I think so.
Come on, man. We have 20 minutes to go.
Yeah, well, 15. I think even we probably want to wrap up early. I think we just need a few more minutes to go through what's already, like, there is essentially a pre-baked web app, static web app in the GitHub repository for the workshop, and there's literally very little that we need to do. This is a Node.js application, so it has some dependencies. So we need to install those dependencies. Essentially, what are those dependencies? The TSI JavaScript client and the Azure Maps client, right? So those are both available on NPM, and those are both libraries that you can use should you want to do TSI and Maps stuff in your JavaScript code, whether it is like client side or server side. Actually, it doesn't really matter. But we have our dependencies installed, and we can now start the app. Just quickly checking that our app is working. What it's going to do, this warning is actually might be confusing, but the way the app is going to authenticate against TSI for getting data, etc., is actually going to be interesting. It's going to be through Azure Active Directory. So, and for that, we need to have a domain name that's already pre-registered in our tenant, etc. I mean, I don't think we detail the instructions in the workshop per se on how to set up your own and register your own Active Directory application, etc. But this is definitely something you should do so that your web app, if you look at the JavaScript code of your web app, it's not like there is any credentials in it, right? It's the authentication is just at runtime by means of folks logging in into your app, which we see here. Well, I'm already logged in because I did some tests yesterday, I guess, but I should and could probably log out and go back. Restart the app. There we go, starting the app. It opens up the browser. Yeah, I'm not logged in. Interesting, not signed in. Go. They just. Yeah, I think I know what's happening. What's happening is that we're just looking at the scaffolding of the web application. In the workshop, you also do some live coding, and you actually need to start and learn and do some reading on what is like the boilerplate code for creating an Azure Maps widget in your web app. What is the boilerplate code for creating and adding some layers to your map. And then once you have your map canvas, then you fetch data from your time series database and you display it on the map. So that's, we walk you through that in the workshop for the sake of the demo and for the sake of time. What I will do, just like often in those kind of workshops, you have like the initial app that we are running right now, and you have the completed version. So I guess I'm just going to swap the two, right? And run off the version of the app that's completed. It's almost completed. It's actually missing the name, the unique name of my, what is the endpoint for my time series database. So I can go and get it from the Azure portal. There we go, from the Azure portal, and more specifically from the TSI like dashboard. This is this guy over here. That's the one. The Azure Map subscription key. Now you maybe like, did Benjamin mention earlier that there shouldn't be any secrets in the app, and everything is done through Azure Active Directory? It should. For this particular workshop, in its current version, it's not using the AAD authentication mechanism for maps. It could. So feel free to open a pull request. Actually, it's all on GitHub. But yeah, in the meantime, let's see. That was the key for Azure Maps. And what is this guy? This is a very, very simple web app. It doesn't like allow us to manage an entire fleet of assets just yet. It's just meant for one particular device. It's just us starting to do some early testing. But that should be enough. And I think that's it. We will maybe spend a few minutes looking at the code later, but let's first check if this works. I actually don't need to kill the app. I could have refreshed it, but npm start. Fingers crossed. Now I do need to log in for sure. We do see the map in the background logging in. Sure, that sounds a bit unnecessary, but why not? But, well, sure, let's log in.
Let's make sure you really want to log in.
It very much looks like AAD authentication, right? There we go. Getting TSI token. I think it works. Yay. I think it works. So that's the past hour of data. I think it's displayed in GMT, but yeah, that sounds about right. 1:45 p.m. GMT. The device pretends it's going back and forth between Redmond and Seattle, and we can see, I mean, check it out in the workshop, but all the cool APIs we used for on the TSI widget side of things to manage the mouse hovering and stuff like that, and the other way around in the maps side of things to manage the fact that we have a heat map that automatically does the clustering, a map and a heat map, which doesn't sound right because maybe our devices are way hotter than they should be. So maybe we can adjust the level at which the heat map, like anything below 32 is cold. And then once it gets 236 and above, it's starting to get warm. So maybe we just refresh and do this quick test. Yeah, that's better, right? And there's only one or two spots now that appear to be hot areas. Can we confirm? Yes, right? That's, yeah, I mean, you see the idea. Just a way for us to show you how to get started with Azure Maps. And with that, I think we're ticking the last box on our like progress tracker. That's done. Profit. How about profit? Like, what? With the 5 minutes we have left, Olivia, will put you back on screen. Do you have any questions that didn't get answered? Do we have thoughts from the folks? Like just right now in the chat, feel free to chime in with the 5 minutes we have left. Maybe I've seen tons of pointers.
Before I
Perfect.
forget, I put the link to all the IoT content at Microsoft Build. So as soon as you're off this live coding session, you can actually go and check out the other IoT content, the sessions, the ones on demands as well, the IoT show episodes, the upcoming deep dives, and some more resources we can add in that post. So I think it'd be interesting to have more thoughts. We've not covered, and that's something which we didn't want to confuse people, but Azure IoT Central it's its own topic. And when I say we don't want to confuse people, it's because you can do similar things. We've basically done, or you've been doing all the work. Actually, I've been just watching you here, and you've been creating an end-to-end solution using the Lego bricks basically. But there's a way also to approach IoT solution, from the SaaS perspective, or and looking into having pre-configured solutions that are made available through templates. And IoT Central offers that. IoT Central is based on all these building blocks. So you should definitely consider IoT Central as a way for you to get started fast, eventually create your proof of concept. And if you have all you need in IoT Central and all the features that are there are super advanced already, you're good to go. But maybe you don't need as much as what's in IoT Central. Maybe you don't need all the UI that IoT Central provides. Maybe you don't need things, or maybe you don't have the level of customization you want or need in IoT Central. And this is where it's super interesting and important to understand how the various PaaS services work under the hood in order to build your own IoT solutions, leveraging all these services that are below there.
Yep. What Olivier said. There's been tons of pointers shared in the chat. The one that Olivier shared more recently with all the announcements, you definitely want to check this out. I'll be sticking around in the chat for the next few minutes for sure. I would love to hear from you all. Olivier and I, we've been thinking about doing this more often. We will, one way or the other, whether it will be on Twitch or not, still TBD, but we do want to interact with you guys. Really interested in learning, in hearing from you on whether you feel it was the right level. I know to some it probably felt like it was IoT 101, but all those tips and tricks I shared, I think some of them you didn't know about, hopefully. But if there are some topics you would like to see covered more, some products, some services, some particular hardware, let us know. You can both find us on Twitter, but again in the chat as well. Would be really happy to. And for those who like Code Hustle, who joined last minute, we recorded the session, so I don't know yet where we'll be posting this, but if the recording worked just fine, you'll be able to watch the replay.
Yeah, I think Paul posted the link to the videos for the Microsoft Developer Channel, so I guess all the build live sessions will be there as well. I think the previous ones are all there, so chances are you'll be able to find this one as well. But as Benjamin was saying, he has a recording, so hopefully it didn't mess up the recording on your side.
It's probably my hard drive is probably getting pretty full now because it's been almost 3 hours, but it was a lot of fun. Sorry, Olivier, about the audio which didn't come through for.
That's okay.
At some point.
No worries. No worries.
All right. I think that's a wrap.
I think it is. I think you've done a fantastic job, and I stood awake. So I think we both did our part here.
Yeah, and thanks to Paul and Dave on in the chat. Like I don't think I was keeping an eye on it. I haven't seen any question that didn't get answered. I think so that was awesome. Thank you. Talk soon. Find us on Twitter and online, and enjoy the rest of Build. Bye.
See you soon. Have fun, guys. Bye.